Hey guys, I'm Nick and welcome back to the new tutorial. Today we will be exploring this dynamic kind of stitching effect, or dynamic inflation if you want, but essentially this is all about manipulating your constraints dynamically inside the Vellum solver. This one is inspired by EJ, also known as iDesign, whose tutorials basically kickstarted my motion design career back when I was in Cinema 4D. So huge respect to this man, and yeah, definitely check out his tutorial if you are using Cinema 4D. But we are getting into Houdini, into the dark side. You can see I have my geometry here, and the only thing I got from my demo, like my setup that I already made, are these groups, or actually like objects that are our paths for our seams, kinda. So let me quickly just walk you through these, and I'm sure you can set up your own with your own kind of shapes and paths, and it will look amazing. So here's my boolean, just yeah, very easy. Booleaning two boxes, one of them is 9.9 and another one is 9. So yeah, I have basically a bunch of boxes. Some are rotated, some are kind of here, and some are to the side, again to the side, and I have a few of them copied like this. And if you merge it all together, you will see it's kind of nice shape, you know. Yeah, we definitely can use some bounding objects, this as a bounding objects for our groups with seams. So yeah, let's begin creating this stuff. Let me drop a null after our merge, and I will call that out static seam. You can pause this video and maybe make some, you can start with a simple, maybe some lines, some cubes over there. So and when you are done with that, let's start setting up the grid. So we will be doing a vertical for Instagram, so 10 and 15 should be good enough. Obviously we wanna as many rows and columns as possible. I'd say that 450 rows and 300 columns, if I'm not mistaken. Yep, this should be good. For the sake of speed, while we are doing some tests, let's just divide this by 2 like this. So now obviously we can create our seams, and let's drop a group. This group, attach the grid to the left input, and our out static seams, should we plug it directly like this? Yeah, I think it should work. So, and here keep in bounding region should be checked, bounding object should be selected, and group type should be points. And let's name it, I don't know, seams. Yep, this looks good to me. The only thing we are missing, I think, is the overall bounding seam, and we should add that. So let's copy, for example, this boolean. Let's attach it here. Oh, nope, not all 3 of them, just this one here. And this boolean should be, for example, 10.1 by 15.1, and then this box should be 10 and 15. And let's just check if this works, because we maybe, yeah, see here we should make it a bit smaller. So it actually should be like this, 9.9 and 14.9, and now we have the bounding seam. All right, now what we want to do is delete everything but not this part, because then we will be driving our pyro from that, and then we will be copying the temperature from the pyro to our Vellum simulation. So let's drop a delete node. Let's move it here, attach here, and let's visualize delete. So we want to delete all the seams and delete non-selected and delete points. So these are the points we are left with. We will be working with these. Now I want to drop another group. Let's call it burn group. Group type should be set to points, and keep in bounding region should be checked. And here I just want to select the bounding sphere, and basically you can go with whatever object, whatever volume, whatever box, but yeah, we will be starting with just this sphere here. All right. Oh, I forgot one thing before it's too late. So for your grid, UV wrap should be checked, so we have all the UVs. And yeah, now let's go to the burn group, and let's now drop an attribute create. Let's plug it in here. For our attribute, we want to go with temperature, set it to be 1, and set it to be only for the burn group. All right, and now pyro source spread. Let's connect it. Visualize the pyro source spread. Visualization set to temperature, and cooling rate set to 0. Diffusion rate noise, we can set it to be 0.1, but we don't have much polygons here anyways. Let's play it and see what we got. So yeah, pretty good. It's a bit too slow. Let's increase the rate to something like 5, and let's see. Yeah, we definitely are much faster right now, but you can see that here we are missing some points, and that's why we need to up the search radius. Let's try 0.2. Yep, 0.2 works, but we want to keep it at the bounding kind of region, the boundary of when it doesn't see the points around and when it actually finds them. So let's try 0.15. Let's check. Yep, it works. Let's check 0.12. Let's see. No, 0.12 doesn't work. 0.13. Let's check again if it works. Nope, it does not. 14. Maybe 14 will work. So yes, 14 works. We have all of them. Yep, at 180. Maybe let's decrease the rate right now. Yeah, and see. I want to aim at around 210, 220. Yeah, this looks good to me. So if you want to just copy the attributes from one geometry to another, but that geometry now has a different point count, because here we have just 4,000 points and here we have 33,000 points. So we need some sort of an attribute to be able to look up when we will be copying this. So before our seams, I want to create an attribute wrangle and create the variable that we all know. PTID equals PTNum, and it should be integer, of course. Best way to visualize it would be dropping attribute copy, and now plug the pyro source spread into the left input, or right input actually, and our group goes into the left input, and we copy our color, but we don't have color for now. Let's add it quickly. Ramp from attribute, temperature from 0 to 10, and now we probably will see it if we go here. Yep, the temperature is here, but you can see it's obviously a mess, and because we should check match by attribute, and here we can set this to be PTID that we just created. So now you can see how it goes here. Obviously it won't be that smooth. We can play with these values here like this, and now you will see how it all goes. Yep, so we don't need attribute copy here, and we don't need this color here. So let's just drop a null and call it out burn. All right, so now what I want to do is drop a Vellum constraints actually, and these constraints should be clause constraints. We can delete this and Vellum clause, configure clause. So plug this one here, and after our clause, let's drop two nulls, one and second one. All right, this one, let's call it out geo, and for the constraints, out con. And now let's drop a dop network, and let's create all the necessary things here. So let's drop a Vellum solver connected to the output. Vellum object is what we need, and let's drop it to the objects to solve here, and Vellum source. Vellum source goes here in the post solve. So for the Vellum source, I want to set the sub pass to be out geo, constraint sub pass out con. Now I also wanna drop ground plane and wanna merge it with my Vellum solver like this, and don't forget that Vellum solver should be on the right side of the merge and ground plane on the left side, and the ground plane could be minus 0.1 at y-axis, so it just don't intersect. All right, so the concept behind this one is pretty interesting. If I drop Vellum constraint properties here, and I want to set this to be stretch group, stretch. Yep. And if I set the rest length scale to be 0.9, let's just take a look at what's going on here. So you can see that this is shrinking like this. So here we are shrinking this class down. What I want to do is actually expand a bit where the seams are. So how to do that would be dropping a sub solver and attaching this to the middle input particle forces of the Vellum solver. And now let's dive inside and see what we have here. So all the actions performed here in the sub solver will be accessible inside the DOP network. So if I create a group right now here and I call it, I don't know, let's create a points, and this group should be pin points, for example. So now here in Vellum solver, you can see that I have this point group, pin points. I have pin points, I have seams, and seams is a static group from the subcontext, like not the one that we have here right now. But pin points is the group that is here in the sub-solver, and it is dynamically updated. So what we can do here is drop an object merge. And in this object merge, I want to select out burn. And now here I have my full geometry with my PTID. So what I can do is attribute copy. And I can copy this attribute, again, mesh by attribute, PTID, and I can copy temperature. All right, so here I now can use color and set it to be ramp from attribute and use temperature to visualize my seams. And here I want to set the temperature to be from 0 to 5. So now we can see that we have, let me just bypass this rest length scale. Right here we have this color, which is a perfect visualization of our seams. And what we want to do is use this in Vellum constraint properties. But using color is one option that we can do. Another option would be to create a group from this color. So if we set the group here to be point group, and let's call it the pin, for example, for dynamic pin. And this base group should be everything that's temperature is more than 0.1, for example, or maybe 0.5. Yeah, 0.5 would be good. So now we have this group that will be updated every frame. And what we can do is, let's bypass the Vellum constraint property for now, and maybe bypass the color because it just messes around here. I want to set Vellum constraint here, and I want to set it to be created each frame with a pin to target constraint type. Group type should be set to points, and group, you can see that we have our D pin, dynamic pins, and pin type should be set to permanent, but very crucial is to match target animation. Let me add a bit of pop wind here so it blows up so we better see our stitches, or actually our pins. So let me simulate a few frames and I will show you how it looks. Now I simulated around 60 frames and now it's not that detailed, you can see, and this is because of the stiffness of our initial Vellum clause constraints. What we can do is reduce this to be possibly the lowest setting. And for our stiffness, I want to go with something around 1. Or actually maybe 10. Yeah, 10 should be better. And let's simulate that exact same number of frames. Now our seams are a bit more visible. But still, I wouldn't say that it's enough. We definitely don't get that much, the bulging here. Maybe we can set the pop wind to be a bit stronger, so we will see how the clause that is not affected by the constraints, it should push up a bit. But it's still not near the final result, and I'm doing this just for the demonstration purposes. Here you can really see how these constraints actually are kind of spreading, the spin constraint is spreading. All right, but that's not it actually. I want to do a few things here. I want to make the seams shorter than they are right now, so decreasing the rest length scale. And then I want the part in between the seams to grow a bit more and have the upward facing velocity. So it's all come down to manipulating the groups actually. So what we want to do here is grab our dynamic pins group. And now I want to set the color. Actually, yeah, we can grab this one. I want to set the color for this temperature. And then I want to add attribute blur to the color and set the blurring iteration to something like 50. I really want to blur it out to this patch. And now I want to create a group and call it puffed. Group type set to points. Base group is everything where CD, or actually, yeah, we need to create an attribute wrangle, actually. And let's type here that fill CD equals CDR. So it's kind of like fill color. And here for the group, I want to select all the points which color is not equal to 0. So fill CD all is for, so base group is at fill CD more than 0. And right now, if I visualize the group, we can see that it's a bit too much points. So more than 0.1 should be better. Yep, should be better. Maybe 0.5, 0.05 actually. Yeah, I think this should work. So now I have two groups. One is dynamic pins and another one is this puffed group. For the puffed group, I want to set the velocity attribute wrangle and set the velocity here to be equal to normals multiplied by fill CD. And actually, we don't need a group here, I think, or maybe, yeah, let's set it to be the puff group. Right now we don't have Vellum wind here, but let's check how it looks right now, because we have velocity, so all the parts that just being stitched basically, because you can see that this group here is very, very similar to this group here. So let's simulate 60 frames again. Oh, and before that, just don't forget to null the color back to white, because it will look kind of ugly when it will be just with these blotches of color. It's really very subtly, I'm not sure if you can see it here, but yeah, basically this is this kind of inflation, but not really inflation. But basically you can see that we kind of see these seams here. To make it more puffy, actually, we will be working with these Vellum constraints. So let's start with the stretch group, I assume, and use the expression should be checked. Rest length scale, we want to keep it at 1, stiffness also 1, and this is very crucial. So here, second input is our DOP data, and our DOP data has all of our groups. So what we can do now is check if we are in the pin group or in the puffed group, or we are not in any of these groups. So if in point group, and here we can check if the point is in the group. So it requires geometry, group name, and point number. Geometry is 1, our DOP data, because it goes 0, 1, and you can see DOP data. Then I wanna check if this is in the dpin group, this particle point actually, so ptnum. Else, if in point group 1 puffed at ptnum, and else for all of our other groups, ptnum. Yeah. So this is our seams. This is our puffed clause, and this is everything else. Cool. Let's arrange it into a bit more neat way. So for my seams, I wanna rest scale to be 1.05 and stiffness to be 10. For my puffed clause, I wanna rest scale to be 1.1. And stiffness, let's leave it for now, let's leave it at 1. And for everything else, I wanna rest scale to be 1 and stiffness to be, let's say 10. And this is only for the stretch group, right? But we have also bend group. So let's copy our Vellum constraint properties, attach the second one into the post solve, and let's name first stretch and second bend. Here we will be working with the bend group, not stretch. And here basically the only thing that we will be modifying is the bend stiffness, because both for our puffed group and our dpin group, we want it to be at really, really low value, like 0.0000001. And the same for the puffed, but for everything else, I actually want it to be at 1. It will remove a few artifacting possibilities. So let's just check how it looks right now. Now, it's not the best way to showcase how it looks. So let me drop a Vellum here in the DOP network. Actually, we can remove this Shift-8 sign, and Vellum object is what we need. And now Vellum post process. And I'm wondering if we actually have normals. Let's check if we add subdivision. Oh, look at that. This looks pretty cool to me. Yep, we have seams, we have our inflated claws. We might want to go into the subsolver and set this V attribute here. Let's just multiply it by 5 so we have a bit more velocity, so bigger bumps. Yep, so now we definitely have bigger bumps. We have these creases here that look pretty nice. The wrinkles, actually, not creases. Kinda now I see that it is pretty simultaneous in terms of how these stitches go. So maybe I would like the stitches to go first and the inflation to go later. So let's go back into the DOPNet and we should remap the color a bit. So let's go back here into the attribute wrangle. Let's check it. So for the color, this color here, I want this group, the pin, to be a bit bigger than this puffed group. And this puffed group is bind to fill CD. What we can do is remap our fill CD. So let's drop a remap, attribute remap here. And for the original name, let's go with fill CD. New name should be left blank. And what we can do now is let's select this group and tinker with these sliders. Yep, so you see here we are growing our group. Here we are shrinking our group. So this looks like the way to go. I think that we only need one other point like this in the middle. And now we should be able to see more of these initial stitches going. So let's simulate again 60 frames. And here you probably see that we have this part here already stitched, but our inflation is only here for now. And this is kind of the way to go here. So what else do we want to do is, of course, make our grid full res, because this will be beautiful only when you have enough polygons, unfortunately. And the longer you wait, the better your simulation will look. In the DOPNet, we can go and maybe increase the constraint durations to 200, maybe set the substeps to 2, not 12. And yeah, we should be good to go with this high res version. Let's simulate 90 frames for now. So now you can see we are running out of memory here, so you definitely want to cache it out to file cache node. But for now, let's run Vellum post process and look at all these wrinkles. Looks really beautiful to me. If you want more inflation, you can always decrease the stiffness or add a bit of more velocity. But essentially, I want to show you a few other tricks that you can use here. So one of them being using an image for your seams. So you can maybe export this UV unwrap. You can just click here, save texture UV to image, and you will have your UV. You can modify that in Photoshop as you wish, or you can grab some sort of a line art image. I will show you it right now. Let me just drop attribute from map, and this really needs more polygons that we were using for tests. But for this attribute from map, I have a texture here in the resources folder. I have this color ID, I think. Yep. And of course you wanna set it where you want. Let's kind of center it here, and for the scale, let's make the scale bigger, translate it back a bit like this. And you can see now we have a pretty interesting image here. And you can use this trick and actually Canada Dry, our fellow Houdini magician from the Cozy Place Discord, he used this function for another scene when he was helping me. But we can use this attribute triangle here, and we can use function called luminance. So essentially compute the luminance of the RBG color specified by the parameters. Parameters would be our CD. And now we can not use this bounding object, but say we want to use all the points where our lum, the result of luminance function, is more than 0.1, for example. And let's visualize our group, and actually it should be opposite, like this. So now you can see that we are targeting a lot of small details, and this could look pretty cool, really cool. I won't be simulating it right now because it will require some tinkering with the parameters, but just as an idea, yeah, 0.2 maybe 0.5, I don't know, whatever. But yeah, I encourage you to try out this line art thing. Might be something cool. And also we can combine two groups, and for example, if you want to use that logo as I used here, we obviously want to invert the luminance like this, and then we want to drop another group called seams. This one should be pointing to our base group called seams, and keep in bounding regions should be checked, or actually no, base group it should stay empty, and this initial merge should be set to union with existing. So now we have everything, and the process is absolutely the same. Delete everything, run virus source spread. Of course, don't forget to visualize the temperature, see how it goes, and yeah, and simulate quite a few frames. Let's go back into the .NET. I want to simulate these 90 frames, and we will be getting to the shaders and lights. And here we have our 90 frames, of course, virus source spread set to none. And what we can do here is grab a few attributes, why not? And what we can do after our Vellum post process is, just to be safe, let me, even after the file Vellum post process, I wanna just cache out just one frame, single frame, explicit skill tutorial, save to disk. So we have this frame and we can work with it. Maybe attribute from map should be that thing that we will be using for the shading, because I haven't saved this color into my DopSim. So let's just drop again color ID, I assume it was. No, I need texture 3. Yeah. So now image settings, let's scale it down or up a bit actually, and translate it to the center, kind of aligning it. Should have done this before sim, and maybe just you know, kind of set the attribute, some attribute to be a representation of this color. But anyhow, colors are here. Let's create a new camera. Let's set it to be vertical, 1080 by 1920, focal length 125, transform 0 out, nope, maybe this one. Yeah, this should be around 9, or no, around 20. Let's zero out the rotation also. 0, 0, 0, and it should be, yeah, like this. Cool. So now let's create materials. So material network, and also add Ares light dome. This Ares light dome, yep, it should be pointing to our Brown Photo Studio. Environment, background disabled, saturation to 0. And in our material network, what we can do is mix two materials. So Ares material 1, Ares material 2, Ares material blender here, and then redshift material out node. So blender material goes into the surface, and these two, one goes into the base material and another one goes into the layer 1 layer color. And blend color should be our Ares point attribute, our point color. So out color goes into the blend color. All right, so let's set this material just for now to be this off gray or dark gray, and this should be white. And both of these materials, just for now, we can set them to be pretty rough, like 0.6. Now let's add new pane tab type. Let's save the project. Geometry, no, let's add new pen tab type, redshift, render view. Set the camera to 1 and hit render. And here we have it. So we obviously want to set our material to our geometry. So let's go here, matnet, redshift material 1, and we kind of have it, but we don't have our material. I have my attribute from map set. We go back to scene view. You can see that we have it. Maybe we should rename our attribute to like mask, then use color here. Let's ramp from attribute or mask. Yeah, it's the same effect. Oh, yeah, it works. Well, cool. So obviously we want to create something more pleasing than these materials here. So RS texture, and this one should be this fabric, which is free texture from the internet. Just roughness and also normals. And now let's plug the roughness into the reflection roughness. And for the normals, we want to set the bump RS bump map here and plug it into the texture input. Bump map goes to the overall bump input. Bump map obviously should be tangent space normal, and these two textures should be raw. Now probably our textures will be too big, so let's scale them down 4 and 4. Actually want to plug the roughness into the diffuse just to check what the scale is for our roughness map. It should be like tiny bumps, I assume. Oh yeah, we see that. Yep, they are in place. So the scale is correct, and let's plug it back to the reflection roughness. For this one, I want to leave it as it is, like plain white without nothing, because this one looks good to me. Let's go to the redshift render view. Let's zoom out a bit. Yep, looks good. Let's restart the render. We have our letters here. And now what I want to do is probably work with the lights a bit. So our slate dome, let's tinker with these rotations. So -30, -30, yep, and maybe 15, no, maybe 5. Or what actually goes if -5? Yeah, I think this contrast is better. I wonder if this seam is a bit too much, too aggressive. But yeah, I think you can play with this and see what type of inflation you are looking for. But I would say we want to add a bit more exposure and a bit more contrast, make it really dark. And yeah, now we just want to render out. So go to the out, redshift ROP, render camera 1. I'm rendering PNG, so let's set it to be PNG. File format PNG. For the redshift settings, you want to go with advanced. Automatic sampling should be turned off. Here, threshold, I want to set it to be 0.003. Here, min samples 16, max samples. I usually go with 512, and then I override for the reflection 512, and for the light also 512. And for the globals, I go with global illumination. Actually, I go with double brute force, 10 and 10. And this is, for me, it's kind of medium between the quality and how fast it actually renders on the farm. So maybe you should also try these settings. Maybe they will work for you too. Yep, here's this quick little setup. I hope you enjoyed it and learned some new tricks inside the .NET working with Vellum. The possibilities there are really amazing. You can do so much stuff really dynamically. I was trying to do that with blend shapes between like regular grid and the inflated grid, and yeah, it's not that. But this technique really keeps the Vellum dynamic and reacting to all the modifications of the constraints that we actually do. Anyhow, thanks so much for being here. I really appreciate you all guys, and doing my best to show you these cool Houdini tricks. And I'll be back next week with another tutorial. Bye!